Today we're talking about concept 2, which is about measuring segments. First up, we know that when we name a segment, we name it like this. For example, AB with a bar over the top, no arrows because it's a segment. But when we have the length of a segment, we say AB with no bar over the top. So like it'd be something like AB equals 5 or something like that, just as an example. So our length, we do not use the bar when we're talking about length. Okay, postulates and axioms. Postulates and axioms are rules that are accepted without proof. And we kind of already talked about this, and you did some counting for me. Ruler postulate. Points on a line can be matched to a number line. And the length of a line segment is the absolute value difference, which you can also just get by counting the distance in between. So let's go ahead and do an example. On a number line, point A is located at -2, while point B is located at 9. I'm going to go ahead and draw that. So here's my number line, and 0 would be right here. So we are counting the spaces in between. When I say absolute value, what I mean is you can't just subtract these because you have some negatives. You got to be really careful. Now, I'm more of a visual person. You can do the absolute value. Like this is an option. 9 minus -2 in absolute value, which is +11 for the distance. That's an option, but for a lot of us, that's kind of confusing because we haven't seen absolute value since like 6th grade. So you can also just go to your number line and count. So the distance from -2 to 0 is 2, and then the distance from 0 to 9 is 9. If you add that up, you get 2 plus 9 equals 11. So when you go to tell me what is AB, you need to say that AB with no bar equals 11. You could also just count, right? Just sometimes you don't have a number line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Moving on to the segment addition postulate. If A, B, and C are collinear, then if A is between A and C, then we can say that AB plus BC equals AC. Geometry is super confusing unless you have a picture. So we're talking about this segment. It says if A, B, and C are collinear on a line, B is between these two, so A, B, and C. I can do AB plus BC to get the whole thing. Like we talked about, this is just a fancy way of saying the little part plus the other little part equals the whole. That's how you'll hear me say it a lot. Part plus part equals the whole. AB, I'll highlight. AB plus BC equals the whole thing, AC. So our example, and this is what you'll see a lot of, if AC is 25, okay, pause, you're going to draw a picture. So we have AC. AC is 25, and then we have B in between it. So put B right here. We know that the entire thing, AC, is 25. It tells us that AB is 3x plus 1, label that. Sorry, 3x minus 1. And BC is x plus 2, also should label that. All right, what is the value of x? So we know that part plus part equals the whole. This little part, AB, so we'll write that down, 3x plus 1 3x minus 1 plus this little part, BC, x plus 2, equals the whole thing, AC, which is the whole thing is 25. So we'll set that equal to 25. And then we can combine like terms and solve. So combine your like terms. 3x is a like term to x. Negative 1 is a like term to 2. Which gives us, this is a 1. Give us a 4x. Negative 1 plus 2 is positive 1. Then we'll subtract 1. Get 24. If you divide by 4, running out of room. X equals 6. So where it says x, we'll say x equals 6. We're also asked to find the length of AB and BC. So we have to take our x and plug it back in. So we need to plug back 6 back in to get AB and BC. I'm going to plug back into BC. Let's see. For BC, I know x is 6, so if I put that right here where the x is, I'll do 6 plus 2. So I know that BC is 8. Because 6 plus 2 is 8. And then you could also plug it in right here to the x spot where 3x minus 1 is, or we could just subtract. I know the whole thing is 25, so if I subtract 8, then I know that AB is 17. You can check your work. 17 plus 8 gives me the whole length, 25. Part plus part equals whole. Okay, next thing we'll talk about is two things are congruent. First up, if they have the same size and shape, so same shape and size, and we note that with a little congruent symbol. It looks like this. It's a squiggle and then an equal sign. So when you see that, that means congruent. Okay, we also talked about midpoint today. Is a point in the middle that cuts a segment into two parts. So a point in the middle that cuts a segment into two congruent parts. If we have a segment like this, A, B, and our midpoint is in the middle, then we mark that they're congruent here and here because those two pieces are the same since M is in the middle. So last practice question, T is the midpoint of the segment PQ. If PT equals 4x minus 8, you should right away label that. And TQ is 2x plus 2, find the value of x. So I was told that it was a midpoint, and you see these little markings here, which tell you that it's a midpoint and they're congruent. So we will set those two segments equal to each other since they were congruent and equal in measure. 4x minus 8 equals 2x plus 2. And we'll solve. This is variables on both sides. So I have to move my variables to one side. I'll subtract 2x. And get 2x minus 8 equals 2. Now we add 8 to undo the subtraction. 2x equals 10. If I divide by 2, then my final answer is x equals 5. So that's dividing by 2. And we get this. Last vocab today is a segment bisector, which is a point, line, ray, or segment that divides a segment into two congruent parts. point, line, ray, or segment that cuts a segment into two congruent parts. So we have something like this, a segment here. You could have any of those things. I'm going to use a line to cut through that segment, which if I am told that it's a bisector, then I know that these two pieces are congruent. So it doesn't have to be a midpoint. It could be something else, a line, a ray, or a segment as well that's cutting it in half, which we call bisect, which means two parts, bisect.